Hello, my name is Mike Pangaron, BSAB student, and I'm here to answer one rotation sample problem for our assignment in dynamics of rigid body. A cord is wrapped around the wheel, which is initially at rest. If a force is applied to the cord and gives it an acceleration, where t is in seconds, determine as a function of time the angular velocity of the wheel and the angular position of the line OP in radians. So, let's analyze. There is a cord wrapped around the wheel and the wheel has a 0.2 m radians. So when the force was applied by pulling the cord, there is movement in the wheel and the line OP changes. So we're going to look for the angular velocity of the wheel and the angular position of the line OP. So by analyzing the picture, we know that the wheel is subjected to rotation about a fixed axis passing through the point 0. So it's not moving from there, only the wheel. Thus, the point P on the wheel has a motion about a circular path, and the acceleration of this point has both tangential and normal components. The tangential components is acceleration along the edge of the wheel, where the cord moves, meaning the acceleration, the force applied is equals to the movement of the wheel, acceleration of the wheel. Yeah. So next step is we're going to substitute. The acceleration applied is 40. Then is equals to acceleration, then the radius is 0.2. Next is we're going to isolate this by dividing it by 0.2, cancel this, 40 over 0.2 is equals to 20t. 20t, the 20t. Let's work. Then our angular acceleration increases linearly with time. Yung ibig sabihin yan. Now we can solve. I will put it here. Babalikan natin yan. Now we can solve for the wheel's angular velocity. We can solve for angular velocity of the wheel. Ito yung omega. So, meron tayong we need the velocity and we got the acceleration. So, by doing this, SVA going right, we're going to differentiate. Going left, we're going to integrate. Since we have already the acceleration, we already have this, and we need this, we're going to integrate. We're going to integrate na. So let's have we're going to use this acceleration equal. Yan. We're going to substitute na. We're going to integrate with respect to t. So 0 to equals to 0 t 20t dt. Tapos ang integral of 20t, ganito yun, 20t, ito may 1 dyan, 1 plus 1, 1 plus 1. So, meaning, yung W na, integrate neto is W. Tapos, ito, magiging, divide to, so 10t2. Yan. So, after we integrate the acceleration, we got the velocity. Using the siya, rad. Forgot the, rad. Yes. So, next thing we're going to do is, since we got already the velocity, we're good. Here, we got the velocity of the wheel. So, in part B, we're going to look for the angular position of line OP in radians. So, let's write here B. Using this, actually, na-bridge natin yung gap. Meron na tayong, nakuha natin acceleration, this, velocity, this, and makakatalo na tayo sa position, which is yung hinahanap natin, angular position. So we're going to integrate again. So let's integrate d, kasi nanap natin yung position, angle position, then we integrate with respect with t. Yung 10 natin, 10t squared dt. So, the same as early. Integration of this is the theta. Next is 10 2 plus 1. 2 plus 1. So, 3 to. Magiging 3 to. So, 3. Divide. Where's my part? There. Sagot is 3.3333 rad. That's the angular position. Ay, ano ba? Yeah, the angular position of line. So, let's go back to the beginning. So, when the cord was pulled, there is a angular velocity. When the cord was pulled with this acceleration, the angular velocity of the wheel is 10 with respect to time. Tapos the position of the OP, the angular position of the OP is 3.33t. So that's it. Thank you for listening.